Algebra 1, Unit 3, Linear Functions, Equations, and Inequalities, Module 5, Linear Functions. Lesson 2, Using Intercepts. Okay, guys, let's get started. So what exactly is an intercept? Our essential question for today is how can you identify and use intercept in a linear relationship? So let's define intercept. So the y-intercept is a graph y-intercept of a graph is the y-coordinate of the point where the graph intersects y-axis. The x-coordinate of this point is always 0. So that's like basically a way you're telling us to, in order for you to find y-intercept, set x equal to 0, right? And if the x-intercept of the graph is the x-coordinate of the point where the graph intersects the x-axis, and that's where the y-coordinate of the point is always 0. So in shorthand, to find the x-intercept, we need to set y equal to 0. Okay? So that's what we can do. Okay, guys. So why don't we slide on and do a problem over here? Okay? So how do you find the x and y-intercept and then graph? Okay. So there are a couple of things we could do. First, we gotta do what the direction says, right? Let's find the x-intercept. So how do you find the x-intercept? As we just learned, y has to be equal to 0, which means that we're going to substitute y for 0. So that just disappears, right? That implies that 3x equal to 15. So what does that mean? So the x is equal to 5, right? Let me actually put that right underneath right here. So what that means, so yeah, x-intercept is just the x value, right? It is the x, so y-intercept is the y-coordinate, x-intercept is the x-coordinate. It's not a coordinate point. It's not coordinate pair. It is just y-coordinate, right? So when you're looking for x-intercept, the answer is just 5, not 5, 0, okay? As you might have learned. But to locate it, though, right, y has to be 0 and x has to be 5. 1, 2, 3, 4, 5, like right there, okay? So its coordinate point is 5, 0, but the x-intercept is just merely 5, okay? And what is the y-intercept? Well, x equal to 0, isn't it? When you do that, it's 3 times 0 minus 5y is 15. Negative 5y is 15. When you divide both sides by negative 5, it is negative 3. Okay, so the y-intercept is negative 3. Let's count. 1, 2, 3. And it's right here. Now, we could just connect these two lines, but what we can do is use this, right? And we just noticed that, let's see, from here to here, that was a 3 and that was a 5, right? So my slope is changing y and changing x, 3/5. So what we can do, if you like, right, go down, let's see, go up 3 from here, 1, 2, 3, 1, 2, 3, 4, 5. It should be around here somewhere, right? Or you go down, you go left 5, 1, 2, 3, 4, 5, go down 3, 1, 2, 3, right here. And when you connect them all, right? Well, anyways, let's do that right there, guys. Okay, that looks about right there. It goes through every point right there, right? So you could use the slope that you see to help you graph. Okie dokie, guys. So you might want to label where this is. This is negative 3, and this right here is 5. And you see this point that we found, guys? That is 1, 2, 3, 4, 5. That's negative 5. And that appears to be 3, 4, 5, 6, negative 6, right? And what you want to do is maybe just plug it in to see if it works out, right? So let's do that, shall we? So we could check negative 5, negative 6. Then If you plug back into the original equation and it works, then you know that this line is what it should be, right? So that's 3 times negative 5 minus 5 times negative 6. Is that equal to 15? That's the question mark, right? That is negative 15, positive 30 on the left-hand side. That adds up to 15. Yep, 15 is 15. We checked it out and it does work out, which means that I am now very confident that this line is what it purports to be, right? That's how you could sort of check your work. Instead of just relying on these 2 points, if you did, what if you made a calculation error, right? So based on what we found, we extend out and find another point, plug it back to the original equation right here, guys. Does it work out? If it does work out, then I'm very, very confident that this is going to work out. Okie doke. Now, what you can do is, I'm going to do the same thing in part B, but slightly differently. Okay? So let us say that x-intercept, I still want you to write this out. X-intercept is when y equals to 0. But what happens when you set y equal to 0? Put your finger over it or put a pencil over it, do whatever you like to do. Then I end up with 6x equal to 24, right? And I'm okay with that. I'm okay with just writing 6x equal to 24 because if y is equal to 0, we know that that right there disappears, doesn't it? So you get 6x equal to 24. Now from here, x is 4. So x is 4. 1, 2, 3, 4 right there. Okay? And then let's try to find the y-intercept. Y-intercept is when x equal to 0. And then if I were to put that right there, x equal to 0, I end up with what? 4y equal to 24. Y is 6. Do you see that? Now let me put that out of the way. So my y-intercept is 6. So let's do that. So you go 1, 2, 3, 4, 5, 6. That appears to be right. And then let's draw a line. Let's try to be kind of careful here, guys. Okay, that looks pretty good to me. So center it right there. And there you go. And then we could find another point. What we can do is use this slope. That's a 6 and that's a 4, right? You go down 6 and right 4. You could do it that way, but also I see the ratio of 3 to 2. So 64 is same as what? 3 to 2. So I could go down 3. 1, 2, 3, 1, 2. Yep. There's a point right there. I could use that point right there. That turns out to be 1, 2, 1, 2, 3. That's 2 and 3. And I should write down 4 over here, 6 over there. Okay, let's check out the point 2, 3 to see if it works out. And if it does, and I'll be very confident that this line is absolutely correct. And my equation is what? 6 times x, which is 2, plus 4y, which is 3. Question mark is that 24? 6 times 2 is 12. 4 times 3 is 12. They add up to 24. Check. Yes, this graph, therefore, is correct. All right, guys. That looks good. So, all right, let me zoom in for you so you could take a look. So that's what it looks like. So you may use this cover technique, whether you use a finger, whether you use a pen, whatever works for you guys, okay? All right, let's go to the next set of question, which should be right here, I believe. Yep, there it is. All right, so find and interpret x and y intercepts over here, right? Ooh. Maybe in class. So there's a find, that is 1, and that is interpret right there. So we're going to be careful. So in Sandia Peak Tramway in Albuquerque, New Mexico, travels the distance about, the tramway, right? The tram travels the distance about 4,500 meters to the top of the Sandia Park. And it's speed is 300 meters per minute, right? It's not the fastest thing in the world. Is that fast, actually? I don't think so. Okay. And the function is the distance of the tram from the top, right? So 4,500 minus 300x, where x is in terms of minutes, right? And yeah, there it is. So what do? We need to find x and y intercept. Okay, let's do that first. Okay, how do you find the x intercept? It's y equal to 0. Now you gotta remember, guys, f of x is y, right? So that is y, which means when you set that equal to 0, we end up with this, which implies that the x is 4,500, let's zoom in, divided by 300. Remember, the zeros could go away. 3 goes into 45 15 times, so x is 15. All right, the y-intercept, when it's x equal to 0, and when you do that, y, or f of x, right, is equal to 4,500 minus 300 times 0. That goes away, which implies that the y is 4,500. Okay, so the picture here is not the easiest to draw, but you know what we could do? I like to have my y-intercept around here somewhere, my x-intercept around here somewhere. I don't want it too tight in the corner, and then I want it as far away as possible within the graph that's given to us, right? What if we do, so this is something you gotta look to figure out. That's 1,000, 2,000, 3,000, 4,000. That right there is 5,000, isn't it? And so 4,500 would be right here. So what I'm going to do is just write 4,500, right? So we know that we can count this easy, right? So we know that's 1, 2, 3, 4,000, and halfway gives you 4,500. And for this one, what I could do is, did I make a mistake over here? 300, right? 315. No, this looks to be correct. So 45 over 3, yeah, it is 15. Okay, so what we can do is maybe this is 1, 2, 3, 4, 5, 10. That's not quite big enough, so 15, 3. You know what, why don't we do it this way? So that's 15 right here. So each one is 5. That looks reasonable, right? Let's connect those two. And here, because we're in the first quadrant only, this is all you gotta do. And this is x, and this is f of x. That is step 1. Part 1, that is. So what do you do in part 2? So what does that mean, right? So we have to give the interpretation, interpret the x and y intercept. So in this particular case, the x-intercept is what? The time that it takes for the f of x to be 0, right? And f of x is what, guys? If you look over here, f of x gives the tram's distance from the top. So x-intercept at x equal to 15 means what? When in 15 minutes, the distance between the tram and the top is 0. It means the tram has reached the top, right? So tram reached the top of Sandia Peak. Okay, so now what is the y-intercept? Y-intercept is y is equal to 4,500, right? That's when time is equal to 0, which is what, guys? That's at the beginning, right? So that just tells you the distance of trem from the top at the beginning, right? So which is 4,500 meters away. Sounds good? All right, guys. Okay. So when you do the part B, it's very similar. So let me go a little bit quicker though, okay? So that is part 1 is looking for x-intercept when y is equal to 0, right? And that 0 is equal to, because f of x is y, and that is 0. So 0 is equal to 750 minus 25x. When you solve for that, x is 750 divided by 25, and I believe that's equal to 30. Yep, it is, right? And what is my y-intercept when x equal to 0? And we know from slope-intercept form, when that's a 0, that goes away, so you're left with 750, right? So that's pretty straightforward, right? Y is 750. So now what do I do? What we can do is, what I'm going to do this. Maybe that is 3,000, 1,500, 4,500. No, sorry. 300, 150, 450, 600, 150. Okay, so that right there is 750 right there. And the x is 30, so why don't we go 1, 2, 3, 4, 5. Let's make that 15. 1, 2, 3, 4, 5. Let's make that 30. So we're going to connect this x and y intercept right here, like this. So we did what we're supposed to. We found the x and y intercept. We connected them. Now we have to interpret them. All right? So here, the 750 is the above the ground. So this right here is always the initial value, right? So y-intercept of 750 is the initial height of the hot air balloon. So I'm going to say balloon, right? That's the initial height before the descent, right? And then x represents the time, doesn't it? So when, and here is y is equal to 0, which means the height of the balloon is 0, which means it hit the ground, right? So what that means is that the x-intercept of 30, and that's in terms of minutes, right, is the time in minutes for the balloon to land. Okay, guys? All right. All right, guys. Now, example 3 is more the same, right? So it's asking you to do the, use the intercept to graph the line described by each equation. Yeah, same thing. So we have x-intercept and a y-intercept. And I forgot to mention this, but what you can do is sort of pause the video and sort of check out to see what you can do and to see if you could match my answers. So what I'm going to do right now is work silently as possible and see if you could match it, okay? If you want to work on your own, just pause the video first. Okay, guys. So here y is equal to 0, which means that that's a 0 right there, right? So using the, where's my finger? There we go. Let's use the finger approach. Okay. So we're just blocking it off, right? So when you cover it up, what do you end up with? We end up with 0 is equal to twice the 1/4 x. And when you solve for that, it turns out to be x equal to 8. Okay. And then when you're looking for the y-intercept, the x equal to 0. So that gives you 1/3 y is 2, which implies that, oopsie, just single arrow would be fine. Y is equal to 6. So when you graph it, so y-intercept, okay, 1, 2, 3, 4, 5, 6, right there. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh, we barely made it. There you go. I extended out a little bit further. Looks good, and that's what that looks like. Okie dokie. Alright guys. And let me work through the second one a little bit faster. Alright. So what you can do is, what is my x-intercept? So we cover up the x. Boom. We're left with 0 is equal to 20x 6. So we know x is -3, right? And what is y-intercept? Please get in the habit of writing, when you look for y-intercept, x equal to 0 and vice versa. Okie doke. Alright. So when you do that, y-intercept, cover this up. So we end up with 15y is 6. So y must be 4, right? Good. Oh, hold on a second. Yeah, that's negative, right? Yeah, we should keep a little distance right here so that it doesn't blend in. So you could say that's -3. You could clearly see how one could have made a writing mistake, right? When you're like really close like this, right? You could easily not see this right here. So be very careful. So I'm gonna keep a little distance so to avoid making mistakes, right? So x is -3. Let's do that. Okay, let's make that green just for sake of clarity, right? X is -3, 1, 2, 3, right there. Y is 4, 1, 2, 3, 4. Yeah, it's a little bit too close for my taste, so I'll go 1, 2, 3, 2, 3, 4. I'm fairly sure this is correct, so I'm not going to check it. But if you see a direction saying that you should check it by finding a third point, please do so. Okay, and there you go. Okie dokie. All right, guys. So let's move on. So you get a chance to do your turn. Pause the video and please work on it. Okay, I'm going to assume that you did. And here are the answers. If you have any questions, make sure you come to tutorial and ask me any questions. This is what we did in class. Okay, guys? All right. Thank you, guys. Have a good night.